In this video, we're going to describe how to use the potential energy for a pair of point charges to apply to a larger configuration, for example, 3 charges. We would like to know how much potential energy does this charge configuration have, where we have one positive 5 microcoulomb charge near two negative 3 microcoulomb charges. In order to use the formula we just gave, which is that the potential energy of a pair of charges 1 and 2, I'll call them, is just Ke Q1 Q2 over R, where R is the distance between charge 1 and 2. Let's label these so we have some consistent naming. 1, 2, and 3. And we're going to use this potential energy formula for each pair of charges. And we have 3 pairs. There's 1, 2, there's 1, 3, and then there's 2, 3. So I'm going to have a potential energy associated with each pair of charges. Now, I want to be clear here. This formula is not for the potential energy of an object. It's for a pair of objects. And in this case, it happens to be that there are 3 pairs and 3 objects. But this is the really only case where you have the same number of objects as you have the same number of pairs. There was 1 pair for 2 charges. With 4, you're going to end up with significantly more different ways of connecting them together. In fact, you would end up with 6 different PE terms for connecting together each of the 4 different charges. So the fact that there are 3 terms and 3 charges is a coincidence in this case. But let's look at the total potential energy. The total is the potential energy from each pair added together. So the potential energy of pair 1, 2 plus the potential energy of pair 1, 3 plus the potential energy of pair 2, 3. So I have 3 terms here. And then the formula I'll be using is this is the kinetic, this is the electrostatic constant, K sub E, times the charge of 1 times the charge of 2, all over what I'll call R sub 1, 2, which is the distance between 1 and 2, which is just 5 centimeters. And I'll call the distance between 1 and 3 R1, 3. Similarly, the distance between 2 and 3 I'll call R2, 3, and that'll equal this 5 centimeters. I'm going to keep on adding all of these terms with the appropriate charge 1, charge 3 over R1, 3 plus Ke times Q2, Q3 over R2, 3, because I'm using this for the pair 2, 3 here. And then I'm going to just plug in the values and solve for the total amount. I do want to note that here it's not the absolute value. This is the actual charge. So if it's negative, I plug in a negative number. Now I don't have space on this slide, so I'll switch to the next slide in order to compute out the total. And I'll reference back to that first slide so we can see what each of the values are. So first it's K, and there's a factor of K in all of these. So I'm just going to pull that out for simplicity. So that's 9 times 10 to the 9th Newton meter squared per Coulomb squared. And then I'm going to have charges 1 and 3 multiplied together. Charge 1 is 5 microcoulombs. Charge 2, I'll use 1 and 2 first. This pair right here is negative 3 microcoulombs. So that comes out to positive 5 times 10 to the negative 6 if it's micro, multiplied by negative 3 times 10 to the negative 6 coulombs, all over the distance between them, which is that R12, 5 centimeters, or in terms of meters, 0.05 meters. My next term is going to be between 1 and 3. 1 is the 5 microcoulombs, 3 is the negative 3 again. The only difference is now I have 7 centimeters between them. So I have a similar term, plus 5 times 10 to the negative 6 coulombs multiplied by negative 3 times 10 to the negative 6 coulombs all over 0.07 meters, or in other words, 7 centimeters. And then my last term is between the two negative 3 microcoulomb charges, which are 5 centimeters away. So I have negative 3 times 10 to the negative 6 squared, because I'm multiplying them together, divided by 0.05 meters. When I plug this all into my calculator, what I end up getting is negative 3.0 joules. I know that it came out in terms of joules because I plugged in originally with SI units. Newtons, meters, coulombs, all of these are SI units. So I'll get out SI units at the end.